Okay, welcome to statistics class, or should I say online statistics class. If you want to use your notebooks and take notes, you can. You don't have to, because unless we come back to school, I won't be checking notebooks anyway. Your notebook grade will just be what it was the last time we took notes, or had a check, I should say. But the title is Discrete Random Variables, and let's go ahead and do a review problem first. And for all of these problems that I have you do, just go ahead and pause the video and then try it on your own. And so I'll be right back. Go ahead and pause it now. Okay, suppose a poll found that 18% of adults have at least one bird, 60% have at least one cat, and 72% of those who have at least one bird also have at least one cat. What is the probability that a randomly selected adult will have at least one bird and at least one cat? The hint is this: when you're doing an AND situation, probability of the first situation times the probability of the second, given that the first one's already taken place, okay? Especially when you're dealing with this kind of a problem. Sometimes the ANDs are just multiplying, but in this type of problem, because you can have a bird and cat at the same time. That's the idea, bird and cat at the same time. You have this formula. All I did here is I replaced all of my A's with a B standing for bird. Okay, so what's the probability of having a bird here? And then the probability of a C, cat. Okay, so all my B's in the generic formula become C's. So you're looking at the probability of someone who has a bird multiplied by the probability of them having a cat, but given, see, right down here, it says given that they own a bird. That's what that line means. All right, so that being said, the probability of a bird owner in the problem is 18%. A cat owner, but given that they have a bird, is 72. See, up here at the top, 72% of those who already have a bird already have a cat. So that's why we change it to this formula here, okay, saying you've got a bird given that you already have a cat, because the question says at least one bird and at least one cat. Well, that's 18 times 72, and there's 12.96% if you multiply that out. Here's another review question. So again, just go ahead and take a minute to try it, pause the video. Okay, this one says a city council consists of 6 men and 8 women. How many different subcommittees can be created consisting of 3 men and 4 women? Well, you're going to use the combination formulas if you remember. The idea is this: you're basically saying how many ways can I take 3 men from 6 and just put them in a group. That's why it's a combination. It's not a permutation. Permutation is where order matters. It doesn't matter who's listed first, second, or third in a group. But then I match each of those ways that I can take 3 men out of 6 with all the ways I can take 4 women out of the 8. So order doesn't matter. You just want 3 men and 4 women. Put all that together, and you do make permutations out of that, but you don't need a permutation formula. It's just multiply the combination of 6, 3 by the combination of 8, 4. You could use that formula or your TI. Using your TI, you should get 1400 for an answer. Okay, for your notes, and again, I can't determine if you're writing this down or not. If you want to just, it's optional because I'm not going to check your notebooks anyway, but a random variable is the outcome of a probability experiment. Let me advise, by the way, to go ahead and take notes because we don't know if we're coming back. Okay, if we come back, you want to have your notes. Okay. Outcome of a probability experiment is a random variable. Discrete random variable, finite or countable number of values. And I'm kind of going quickly on this because you can always just pause the video if you want to write some of this down, of course. And then a continuous random variable is infinitely many variables determined by measurement. If you remember, we've already talked in the past, something that's discrete is countable, okay? How many students in a class? 15, I can count them. But a continuous random variable is measurement. All right, if I measure you as being 5 foot 8 inches, you're really not 5 foot 8 inches. You're 5 feet, you know, and maybe it's 7.86543 inches or something, okay? It's not finite. So here's how we would graph those. Discretes are always just actual numbers, but continuous, anything between, all right, 2 and 6. Random variables are denoted by capital letters, capital X, T, S, etc. But the values of the random variables are denoted by lowercase letters. This will make more sense in the next example. Again, pause it if you're copying it down. Identify the data in each situation as either discrete or continuous random variables. Then identify the random variable with a capital letter and the possible values of the random variable with a lowercase letter. All right. Here's the two questions. I'm just going to give you a few moments to try and figure that out or answer those questions. Again, pause the video. Okay, first question says, the speed of each car that passes a state trooper and the number of students receiving A's in a math class with 20 students. Hopefully you figured out that the first one is continuous. Okay, if you're clocked at a certain speed, it's not an exact speed. They round it off. So it's continuous. Discrete, though, we can count the number of students in a class. I don't have half of a student or something. All right, and here's a little more explanation. Speed is not a finite number. You may be clocked at 45 miles per hour, but your actual speed is anywhere, or it's any amount, from 45.5 to less than 45.5. Because if you were speeding at 45.6, the radar gun would mark you up to 46 miles per hour. So anything that's between 44.5 to 45.5 is a speed of 45 miles per hour with the rounding idea. So look what I have here, lowercase s for your speed. Now, part B is this. Capital S is how I identify the random variable, okay, right there. But the values is a lowercase, okay? So the values of the random variable are lowercase. Same with the P for students, okay? Random variables versus value. So again, random variable is capital P. How many people in the class? Lowercase p. How many people in the class? I didn't use S because I'm using S already for speeding. For your notes, probability distribution, the possible values of the random variable X and their corresponding probabilities. Take a moment and pause it if you're copying there. All right, and here's what an example might help you make a little more sense out of this. If you're playing basketball and we say the probability of a basketball player's probability distribution of making 0 out of 3 shots, 1 out of 3 shots, 2 out of 3 shots, or 3 out of 3 shots when shooting three free throws, okay? So, you know, when you're shooting on the foul line, at most you're going to shoot 3 if you get a 3-point shot there. But probability of making none of them, making 1, making 2, or making 3 is determined by some player's data. Okay, this is something we just made up. Okay, this is just made up data, but it's made up based on, you know, what this player has shown in the past. Okay, who's a good basketball player in our class? I don't know. Maybe we'll say Keller Rock. He's a wrestler, but he probably shoots baskets too. So Keller went to the foul line and he did a bunch of tests, and it was determined that his probability of getting 3 out of 3 was 51%. Good job. All right. But the random variable would be capital X. Now, if you want to use capital S for shots or capital P for points, it doesn't matter. It's just the point is a capital letter representing shots made. And then the value of the random variable is either going to be 1, 2, or 3. So we use a lowercase x, lowercase x. All right, you try, and I've already given you some of these answers, but see if you can figure this out. Pause the video and answer these questions. Okay, from this example, identify A, the type of random variable. Is it discrete or continuous? A capital letter to designate the random variable, and possible values of the random variables, and then determine P of 2. Well, hopefully you realized it was discrete. All of this is discrete data. You're not making 1.5 shots. You're just making 1 shot or 2 or 3 or none. And then the capital letters I already did was X, but you could have chose anything. You could have chose, S for shot or P for points, anything you want. Just be consistent. Whatever your capital letter is for your random variable, your discrete random variable, the values are a lowercase of that letter, and those values are 0, 1, 2, or 3. Probability of getting 2, it should have been obvious, 0.38. Now, note this as well. Part D, the probability, it's read like this. The probability that random variable X equals 2 is 0.38. Okay, don't copy this unless you really need to, and you'll see why in just a moment. Let P of X denote the probability that the random variable X equals lowercase x. Then we have this. All of the probabilities add up to 1, and all of the probabilities are between 0 and 1. That's why I said don't worry about copying it, because we've done this before. You should know that when you do probabilities, adding them up makes 1. Remember, this is the summation key, if you forgot that, okay? I know it's been a couple of weeks, so summation, you're adding up the probabilities. Each probability falls between 0 and 1, kind of like back here. Each of those are all less than 1, and they total up to 1 if you add all those up. Okay? Now, which of the following represents a discrete probability distribution? Pause the video. I'll give you a moment to figure it out. B is the only one that represents a discrete probability. A has a probability in it that's less than 0. There's no probability that's negative, okay? So that eliminates this as being a probability distribution. C, all the probabilities, they total up greater than 1. If you add all those up, you're going to get a number that's greater than 1. So adding these, they're all less than or between 0 and less than 1, and totaling them up makes a total of 1. All right, when graphing discrete probability distributions, the horizontal axis is our discrete values, and the vertical axis is our probabilities. So there's X representing, 0 shots, 1 shot, 2 shots made. Probability of making none is 0.01, just a little bit above the line on the y-axis. Okay, so 1 being 0.10. And this is the graph of our basketball players' data. Is this distribution skewed left, symmetric, or skewed right? It's skewed left. Remember, put your hand down. Okay, there's your left hand, and there's your right hand. All right, and it's all going down towards the left, so that's why we say it's skewing left. Try this problem on your own. I'll go ahead, or you go ahead and pause the video, and I'll be back. Okay, they want you to determine the mean of this data. Well, a simple way is just to add all those up. Add up 2, add up to 4, 6 to 6, 4 to 4, 2, 3, 5. All right. And then problem 2, create the discrete probability distribution of this data. Well, we got to think about it like this. How many 2s show up? 1, 2, and there's 10 that are total, so the probability of a 2 showing up, that's what P of X is representing here, is 2 out of 10, or 0.2. How many 3s show up? There's 1 3 that shows up, so the probability of a 3 showing up is 3 out of 10, which would be 0.03. No, 0.30, sorry. Okay, 0.3. All right, so your data table should have looked like this. 0.2. What am I doing here? Yikes. My bad. Not 3 out of 10. If I make a mistake, like it is in class, I'll have to catch it. No one can catch me. There was only 1 3. Okay? There was only 1 3 in there. So because there was 1 3, it's 1 out of 10, which is 0.1. All right, thank you. Don't erase anything. You were right. All right, so there were 2 10s. There were 2 2s. There was 1 3. There was 3 4s. There was 2 5s. There was 2 6s. So 2 out of 10, 2 out of 10, 3 out of 10, 1 out of 10, 2 out of 10. Was your mean 4.1? Again, all you had to do, add up all those and divide it by 10. So it should have came to 41 divided by 10, giving you a mean of 4.1. All right, to use this data, use this data to verify the mean, observe this. Now you don't have to copy this. You're going to see it on the next page, the main point you're going to see on the next page. But just follow the logic here for a minute. Again, we're trying to verify that the mean is 4.1. You've got all those numbers there divided by 10. That would be one way to just get it quick. But watch what else we could say. Because the number 2 shows up twice, I'm multiplying 2 by 2. Because the number 3 shows up once, I'm multiplying 3 by 1. Because the number 4 shows up 3 times, I'm multiplying 4 by 3. 5 shows up twice, so I'm multiplying 5 by 2. 6 shows up twice, so I'm multiplying 6 by 2 and dividing by 10. No problem there. Well, the idea is the probability of 2 showing up is 2 out of 10. 2 times the number 2 showed up. 1 time the number 3 showed up. 3 times the number 4 showed up. 2 times the number 5 showed up. And 2 times the number 6 showed up. So if you look what I'm doing there, I know you might say, well, you're just multiplying by the probability. True. But I'm getting that by saying 2 divided by that 10, 1 divided by that 10, 3 divided by that 10, 2 divided by that 10, 2 divided by that 10. What that means is 2 times the probability, 3 times the probability, 4 times the probability, 5 times the probability. These are all the probabilities of a 5 showing up, okay, in that case. Multiplying all of that out, if you took the number 2 and times it by its probability, 2 times 0.2, 3 times 0.1, 4 times 0.3, 5 times 0.2, and 6 times 0.2, multiplying all that out and adding all that, I should say, multiplying and adding, will give you 4.1. Now here's the main point. Copy this in your notes right here. To find the mean of a discrete random variable, you can use this formula, okay? This formula. What we did to find the mean was we added up each individual value times its probability. I don't get it. Okay, check this out. Again, right here. There's the value 2. We times it by its probability of 0.02. And we added it. See? We added that probability right down there to the one with 3, to the one with 4, and so on and so forth. Okay? And that's all this is saying down here. You had a 2 in your data. You times it by its probability. You had a 3 in the data. You times it by its probability. A 4, a 5, a 6, and you add all that up, and you will get the 4.1. That's what this formula is saying for finding the mean of a random variable, discrete random variable. That being said, let's see if you can use the formula to try this one on your own. Go ahead and pause the video. Okay, let's see what we get. You should have got 2.4, and if you didn't get 2.4, let's see why. What you're taking according to the formula is 0. The first little x value is 0, multiplied by its probability of 0.01. Then you add that to 1 multiplied by its probability of 0.10. Then you add that to 2 multiplied by its probability of 0.38. You add that to 3 multiplied by its probability of 0.51. And putting all that into your calculator, you're going to get 2.4. But what does this mean? Again, it has to do with average. What does it represent if it's average? You don't need to copy this, but the mean of a discrete random variable is the average probability outcome expected if an experiment were repeated many times. If our basketball player were to shoot free throws 100 times, if they were to shoot 3 free throws 100 times, okay, that's 300 shots altogether, we would expect that on average he would make 2.4 shots out of 3. Out of every 3 that he takes, we're expecting 2.4. So what would that be? If you do 100, 240 shots, would be made if you shot 300 times. So for your notes, copy this though. Expected value is simply the mean of the discrete random variable. It's what we expect the average probability outcome to be. All right. So in this case, the average, 2.4 out of doing it just 10 times, in our case. No, I'm sorry. He's going to make 2.4 shots out of every 3 he does. Okay, out of every 3 that he does. So again, if you do 100, if you do 300, we're expecting you're going to make 240. But expected value, it's what we expect the average outcome to be. All right, an 18-year-old male purchases a $250,000 life insurance policy for $350. Research shows that the probability that the young man will survive the year is 0.998937. Determine the expected value of this policy to the insurance company. Now, we've done problems like this already, so hopefully you remember this idea of basically it's saying, most young men are going to live, all right, 0.9939, that, you're surviving the year. It's very close to 1. So let's do this. Determine how much the company will gain if the man lives and how much it will lose if the man dies. Go ahead and copy this table down and pause the video if you need to. But the reason your two values, your two x values are 350 and negative 249,650 is because you've already given the company $350. All right, if they're going to pay out $250 in the event that an 18-year-old man passes away, well, they've already collected $350, so they're only losing $249,650. Take your $250,000 and subtract $350, because that's what they brought in. They already got that money. So they're really only losing $249,650. But now we look at what's the probabilities of that. Well, the probability of the $350 versus the probability of the $249,650. If you figured that out already, great. If you didn't, but here we go. Determine the probability of the man surviving the year. Well, the probability of surviving, we already said, was 0.998937. So the probability of passing away is 1 minus 0.998937. After all, you're either going to survive or you're going to pass on. Okay, so your probability of passing on is very low. Your probability of living is very high. These two add up to 1. Okay. All right, so what do we do? Determine the expected value, which is simply the mean of the discrete random variable. Well, what do we do to find that? Okay, the formula says add up each random variable, or each value of the random variable, times its probability. There's your value of the random variable, x, times its probability, added to a negative, 249 is the other value, times its probability. And when you do all that, you should have got 84.25. Okay, if you got that, great. If you didn't, go ahead and try it again. Or just pause and contemplate this for a moment. Think about it. In our last example, the insurance company expects to earn $84.25 on each 18-year-old male it insures. But this is a long-term result. In other words, as the experiment of insuring young men is repeated many times, on average, 84.25 is earned on each male. Okay, as they just keep on insuring more and more and more and more. Few of them are going to pass away, and it's going to average it out so that on average, they brought in $350. You might say, well, that's a lot of money they're bringing in on each of those young men. That's right, but they're only earning 84.25 because the few that pass away are going to eat all that money up. But they're still going to be left, though, with a profit of 84.25 on average for each male. All right, standard deviation for your notes. Now, this is a different kind of standard deviation. It's the standard deviation of a discrete random variable. So pause the video and copy this formula. And as always, the variance is the number under the radical. All right, notice this formula. And we're going to do it by hand for our basketball player situation. Determine the standard deviation of our basketball player's data. You should get about 0.67. Pause the video and try this. Alright, if you were lost, here's what's going on. You're looking at the square root of the summation of each value squared times its probability, and then minus the mean squared. And we already know the mean is 2.4. That's why I put that in there on the side for you. Alright, so what's going on is this. You're looking at 0 squared as your first value times 0.01 added to 1 squared times 0.10 added to 2 squared times 0.38 and added to 3 squared times 0.51. Now, add all that up, okay, I'll put that into a big, like that, and then take away 2.4 squared, and I'm sure you all are capable of doing that into your calculator, but when you do, it comes out to being about 0.67 when you round it off. Okay. Last question, what would be the variance? The variance was 0.45, because when you add all of those and subtract 2.4 squared, under the radical you should have got 0.45. That's called the variance, whatever's under the radical. The square root is the standard deviation of a discrete random variable. Okay, go ahead and copy the homework down. Like I said, I'm not going to be collecting the homework, but you're not going to learn this very well if you don't try some more problems. So go ahead and do the homework and have a good night, and expect another video to be sent tomorrow.